All right, and I think we are live.
I think yeah, cool. I think we're live on the internet.
Awesome.
One of the
Okay.
scariest places to be, and most exciting.
Hey, but it's like if you're like prepared to do some live coding, super scary place. Super scary place. All right. Okay.
Okay, so we've got studio chat and live stream chat. Awesome. Okay, great. Very exciting.
All right. And I think we are set up. Nice. Okay, cool. What are we gonna do today?
Well, word on the street is Dominic Torno's going to build a durable execution from scratch in Python with Django. That's what I heard.
Actually, true. Yeah. So today, it's like I'm gonna try to build a Django app from scratch. That's gonna be a challenge and a half. I haven't done that in a while. I did some preparation, so it's like that. Nobody sees me like stumble around from like beginning to the end. But yeah, let's see how far we get.
Cool. So, real quick, for anybody who's jumping in here and is not familiar, you're pretty much a distributed systems OG engineer with decades-long experience learning about and educating others on how to think about the complexities we face in the distributed application world. And I'm coming in. I'm Cully, and I'm coming in with a background in supporting software ecosystems through docs, developer advocacy, education, and I've been a huge fan of yours for a long time, ever since we
Oh,
met.
thanks.
And I'm super excited to be doing this with you. So yeah, cool. So yeah, our intent is to uh, hopefully show show the very specific implementation of durable execution in this little environment you created. Some very some key takeaways that people will have. Correct me if I'm wrong, but some will be able to very clearly show the difference between without recovery and with recovery from this example.
Exactly. That's the intent. So the first the question is what is a durable execution, right? And with most things in software engineering, if you ask three people, you get five different opinions. And so what we are going to focus on today is that we will look at durable executions as a unit of failure tolerance. More specifically, as a unit of failure tolerance via recovery. So if you have a process that may crash, right? If you have a process that may crash, you recover that process by restarting the process generally, right? There are of course optimizations as well. So some of the processes do checkpointing or snapshotting so that you do not restart them from the beginning. But in either way, or in either case, you have to restart the execution, right? And then the execution itself can determine if it's going to start from the very beginning or if it is able to fast forward to a certain point in its previous life cycle. But so that's what we're going to implement today, right? So it's like how can we make an execution resilient towards crashes, right? If the execution crashes. Now there are two levels, at least two levels we need to look at, right? Because no execution stands on its own. An execution, like a function execution, always exists in a container, right? That is like there's an executor relationship, right? And so if you have a function execution or n function executions that currently execute in a process, when the process crashes, what do you do, right? And so because with the process, the executions crash. So there's a two-step situation here, or a two-level relationship. First, something has to recover that process, right? That's not going to be our application. Our application exists within that process. So something has to recover that process. That's going to be us. In this case, if I kill the Django process, I'm going to restart the Django process. Okay, it's not going to come back by itself. However, after I restart the Django process, so what we're trying to do is that we recover all of the executions that were in flight and that crashed with the Django process together. That's what we're going to do today.
Awesome.
All right.
Awesome. Yeah, it's always a really great point to make that we are aiming to recover the executions, the computations in the process, and we will be manually restarting those processes ourselves. But there's a whole suite of software out there aimed at recovering those, or restarting processes for computations to restart in. But durable execution is aimed at the recovery of the executions themselves.
It's a very fundamental relationship that we generally do not call attention to, right? And so, for example, databases. What's the main execution in a database? It's transactions, right? What's a transaction? A transaction is a sequence of steps. Right? So the main unit of execution in a database is transaction. So if the database crashes, right, the process of the database crashes, right? Nothing within the database is going to recover that process, obviously, right? Because it just crashed, right? So sorry for the dark imagery, but I cannot give myself CPR, right? If I am in need of CPR, I rely on somebody else to do that. Database is the same thing. Something else needs to restart the process of the database. After that, the database itself goes through recovery. That is, it recovers its executions, its transactions. Right? And in case of databases, the transactions were in mid-flight. That particular recovery is a rollback. Right? So there is an OG of reliability and recovery and supervision, right? That's Erlang as a language environment, and Beam as a runtime, right? And there we talk a lot about supervision trees, right? They're very sophisticated, very, very cool, like a supervisor supervising other supervisors and so on and so forth. But eventually we kick the can down the road, right? We reach the end of the road. If the beam crashes, none of the supervisors that exist within the beam can do anything about that. We rely on something else to restart the beam. From there on, we can totally recover whatever ran in the beam, but we need something else to start the beam. So, and as you mentioned, there are tons of platforms, right? So it's one very prominent lately is definitely Kubernetes. Kubernetes is the one where it says, hey, your container crashed, I'm going to bring it back up. Right? So that is the external recovery. And then there are the internal recovery. In this live stream, we only going to do the internal recovery. External recovery, I just going to restart this manually. Right?
Awesome. Cool.
All
so
right.
People following along, you're gonna build this from scratch first, do some coding, whatnot, and if people
I'm going to give it a good try.
If people want to try this out afterwards, at the end we'll post a link to the repository where we'll upload the code that you've built.
All right, let's do this. Let me see how I can share my screen here.
You'll be given several options, either a specific application or window or the whole screen.
I think I want to do a screen. I want to share this one. Whoa.
The never-ending mirror.
All right, so now, can you see my screen?
Yep, looks good.
Awesome. Awesome. Then, all right, we're gonna start. Implement. We're gonna start with like a normal Django application. Yeah? So back in the day, I started with what was it called? Ruby on Rails. Yeah, of course. Started with Ruby on Rails because around like 2006, 2008, everybody did Ruby on Rails. So I started with Ruby on Rails. But then eventually, I discovered Django as a web framework, and then I cannot really put my finger on it why, but no, actually I do know why. Django captured my heart, and I think it was the admin interface that Django automatically provides for you, and that is like I fell in love with, and then also the rest of the framework is pretty awesome. So in this case, all we're gonna do is we're gonna set up our Python environment, right, and then
it's funny. I know Rye has been labeled kind of experimental, but man, I can't think of going back to using anything else after trying Rye for managing environments and dependencies.
you know, I have to say I love Python. It's my go-to language when I want to try something. But I have always struggled with first installing it, yeah, and then second, every single time I want to set up a new environment, I'm struggling with it. Yeah. So and then Thomas, our teammate, introduced me to Rye, and gotta say, it's like I'm in the same boat. I'm not going back. I like it. Yeah? I like it.
Yeah.
All right, so we're just creating a normal Django project with the Django CLI, right? Then we migrate, basically adding all the default tables to Django, and now we create a super user so that we can log into this awesome admin interface. And there, we're going to be like super creative.
Admin.
Exactly. Don't tell people about my master password. No, I'm not that bad. Even Django says don't use it. Yeah, but we're gonna override it and say, yeah, we want to use it. All right, so now we got this super user, and all right, let's see what happens here if we try to run the server. It's like, all right, so where's my browser? I will find it in a moment. In the meantime, I'll navigate to localhost. Here we go. So, okay, our Django project is set up, right? So now we got a bare bones empty Django project. It's like, so far, yeah, there's nothing to it. So far, there's nothing new. And now I give you a quick glance at why I fell in love with Django. That's automatically generated admin interface. That thing is just so cool. Sure. That thing is just so cool. Yeah. So for any model, so Django's ORM, right, object relational mapper, its main abstraction is a model, and a model basically maps to a table. And for every model, it generates a full admin interface, right, like right out of the box. You don't have to do anything about it. It's really cool. Yeah. And
awesome.
that is what, yeah, it's awesome. It made me fall in love with Django right away. All right, but now we're gonna get started here on adding some of our own stuff. So, okay, that's our thing, and that's our Django application. Right? This is the just a getting started thing. Okay, so what we're gonna do? we're gonna add a function. Yeah. Like in our business logic, we add a business logic function. Our function is called foo because my favorite function name, so it's called foo. And all we're gonna do there is basically like sleep for 15 seconds, right? Let's make it long running, because otherwise we don't really have a chance of like killing it in the middle. So it's gonna sleep for 15 seconds, and then we bind that to a view, and we bind that view to a URL so that we can call it in the browser, right? Or on the command line. Good enough. So we call it on the command line, and yeah, that's where we're gonna go here. So let's add a thing, business, because once again, I'm super creative. So add our business logic, and then let's say foo.
Fair enough.
And again, foo doesn't do much. So we're gonna sleep a bit, and then we're gonna sleep for 15 seconds, and then we return. Yeah, it's just, yeah, exactly. Why not? Let's be a little more adventurous here. We return a random number from 1 to 100. All right, that's it. We don't do anything else. And of course, we just import the time and random here. All right, that's our business logic, right? So it's like, so far so good. It's not pretty much self-explanatory. Okay, after that, we want to be able to call that from the web, right? So Python Django defines views, right? So a view function. It's a view function that we can bind to to a URL. Right? Okay, so we'll define let's call it view foo. We define view foo, and there we get a request, and then we just call foo directly. And then what we're gonna do, we get a random number, we're gonna call foo, and then we basically just return no, let's do a JSON response, and sure, the result is R. Okay, that should do it. Okay, then we need the Django stuff. Yes, we need the JSON response, right? And then from almost we need business, and then it should be our view.
Cool.
Okay.
So we can call view foo from the command line or the browser.
Yes, no, not quite. We're missing one more step, and that is we need to bind that to a URL. And so we're gonna add one more file to this, and that's urls.py. Oh, already in there. Fantastic. Never mind. And we're just gonna edit this. Okay, we don't need that. So it's our admin API, and then no, that looks about right.
There we go. That's the last.
Perfect.
Step there. Got it.
Perfect. And then we also from exactly so. And oh, hold on, that's not right. We'll implement from the hold on, not the business directly. We need the views. Okay. All right, that's about it. And then now we can call, what did I say?
would be view foo. Yeah.
Let me double check here. I said foo.
Or maybe you're right.
Oh yeah, and of course, yeah, it's like starting the server is always a good idea. Because without the server, nothing's going to happen. And now, of course, we got to wait a little, yeah, because our super long running process runs for like 15 seconds. Okay, maybe I overdid it with the 15 seconds, but it's like that. That's basically the idea here.
There you go. Cool. Random number 67.
Here we go. So now, question is, so this is basically what we do, right? So it's like we now have a Python process. Let's call it a Django process from here on out. We have a Django process. That's our environment, and the Django process executes our functions, right? So the Django process basically, you can argue, or you can think executes the executes a view in response to a request, and that view executes the function that we call it. So let's think in two levels, right? So we have the Django process, and there are function executions, full function executions in there, right? Currently, none, because that already did it, right? So there was only one. Currently, one is running, right? Two are running. Three are running, right? So now we have three running function executions in the machine. So what happens if we kill the process in the middle of it, right? If we kill that process, then I think it wasn't fast enough. No, it was not. But if we kill that process in the middle of it, right? Every single function execution that was executing crashes, right? So when I restart the server, obviously everything that was already running is not going to like magically run again, right? Now there are several options, and the most common option is that it is the client's responsibility to restart, right? And the client basically has to be around, has to watch the connection, right? And so something crashes, and when it crashes, it has to retry. Right? So you basically make the client not only it's not only the service consumer, the client is also the supervisor, right? So you have a service consumer, that's a client. You have a service provider, that's a server. But there is a separate role that the client assumes, not only the service consumer but also the supervisor. And if it notices that something fails, it has to retry, right? Now the idea of durable executions is that an execution can recover by itself. And it's like, is that important? Well, yes, for various reasons that is important. First off, if you have a process that consists of 3 steps or 5 steps, right, and it crashes after the second step, then there is a good chance that your system is currently in an inconsistent state, because generally a system is only in a consistent state if we execute something to completion, right? Therefore, if the client doesn't stick around to be the supervisor, right, or if the client doesn't retry, system may be in an inconsistent state. So it is beneficial if you separate that notion of the client is the supervisor from there is a supervising component somewhere, right? So that these two roles are separated. So once the client kicks off the request and the request itself is persisted, right, then something will make sure that we execute this to completion, right? So and that's basically what we're going to code right now, right? So that's what we're going to add to the system. And there's like few requirements. What are our requirements? So a lot of times how this works is that we add a different component, something like celery. In the case of Django, it's celery. It's a message queue, right? Interestingly, we have to change the entire flow then. We're not calling a function in line. We're not just a view doesn't just call a function. A view puts a message on the message queue. So I'm handing off that message to like a completely different system. Now, my function invocation is actually more or less a remote function invocation, right? So it's like, now I have a worker sitting somewhere. I need to deploy that code separately, right? So it's like now that the whole shenanigans, right? It's like we don't want to go there. It's like what I would like to have is basically I just want to put my function in a box, so to say. I use that terminology. I steal that, borrow it from the functional community and the effect community that says put your function in a box, right? And that box adds additional properties. So ideally, I want my function. If nothing happens to it, I don't want the semantic to change or anything. I just want it to be a function call if nothing happens to it, right? But if it crashes, I wanted to, in the odd case it crashes, I wanted to recover. And if you put something on a message queue or whatnot, it's different, yeah? Because there it's not normal. In the normal, it's not just a function call; it's a remote function call to begin with, right? So I would like to avoid that in our implementation here. Yeah? So you can argue that has its merits as well. Don't get me wrong, but here we just want to be able to put our function in a box. So first thing, what do we need to do? We need to be able to persist the request itself, right? So that we can, the recovery will basically be, well, we restart the function and the restart is or the function invocation itself is represented by the request. So we're gonna persist the request. Or the function invocation. So we're gonna call that thing, we're just gonna call that thing a task. Now, now it actually also gets a little bit more fun in the sense of like Django, because now we're gonna add our first model to it. So first and only, actually. So, but we add a model to it, and we say that is right. Oh, come on. From Django.
Come on, autocomplete.
Now it is. That was my fault. And nice food. No. We're gonna the box that we call the box. I call the box now a task. Okay, we're gonna put our thing into a task. So I was like, no. And so first thing we need for a task is we need to say, well, what is it, right? So it's like what is status of the task. So man, me and typing is painful. What's the status of a task? So max length, let's say 50, because always 50. And then we're going to do we have some choices here. It's like pending, completed. Not bad. Okay, that's true. So that's the first one, right? So the task is still ongoing, right? Or the task has been completed. So fantastic. Because if it is ongoing, right, we need to recover it in case of a crash. If it already is completed, we don't need to recover it because there's nothing to recover. We already did it. So then we add another one. No, we don't need a UUID field here. We're just gonna do okay. So now we also need to give it an ID, right? Because that is somewhat of a departure, yeah, from our model that we were able to enjoy so far. Because so far, logical identity and physical identity of the function invocation and the request was the same, right? But if it crashes, I want to recover it, right? I want to restart it. But in software engineering or in software, there is no such thing as restart. It doesn't exist. You can only start something new, right? So once a process crashes, I can never get it back, right? It's gone. It's like, this is a little bit of a philosophical question. It's like, can you jump into the same river twice, right?
A little bit like if you clone yourself or you copy your consciousness, are you the same person?
You can take that pretty far, actually. You can ask yourself, if you trim your beard, are you still the same person? No, not to get too deep. But now we basically need to carry forward that identity, right? And we actually just give it an identifier. That's how we carry forward the identity. So we have two different function executions, right? The first function execution crashed, and then we're starting a new function execution. But we just consider the new function execution equivalent, right? And in order to track that equivalence, not even equivalent, identical. And in order to track that identity, we actually give it an identifier. So that's what we're going to do here. But we also need to 50 is probably not enough for that one. You know what? Let's be generous here as well.
And to kind of map to what you were saying, the ID basically it's logically equivalent, but spanning two different physical or multiple physical instances.
Yes, it's the same execution on the logical layer, but it's two different executions on the physical layer. And in order to tie them together, we need the identifier. And actually, no, not for the failure. We don't want a JSON field. We just want a text field. I think that's about it. We have a status. We have the ID. We track what function we want to call, right? We track the arguments that we want the function to give. We track its status, whether not status, return value. We track its return value if we ended in success or in failure. And then, you know what? Let's just something to that effect. Not the function. Let's do the status. Okay. All right. That's our first model. So now we have a model, a database table. So what do we need to do? We need to migrate. All right, we need to migrate that baby. And okay, let's do that. That would be manage by make migrations. If I'm not totally off, save what app durable. Okay, then there is something to that. Okay, already starting to go haywire. And that is, where are my settings? Here are the settings. Installed apps. We need to register our own app, if I'm not mistaken. So let them make migrations. Find it. There we go. So now we have a migrations folder. Yeah. That migrations folder is gonna, when applied, alter our database. And let's see if that works the way we want it to work. Migrate. All right, we have durable in session. Okay, cool. So we have the thing ready. Now, before we keep going, we also add wrong folder. We also add some super cool thing. We add an admin API. I'm sorry, an admin UI. So that is, and then you're going to see why I was in love with Django, because that's just freaking awesome. And we need from the models,
cool.
We import the task.
watch the tasks that you just created?
Yes, with a super slick, with a super slick UI. So we want first do the status, then we do the UUID, then we show the arcs, success, and failure. That's, well, you know what? That's enough. That is it. Okay, cool. Then we register it. Boom. Okay. That should, oh, and once again, it's always a good idea to start the server. Okay, cool. Here the task showed up. Huh? Pretty slick, huh?
Nice.
So, yeah. It's not bad. It's not bad. Now we can add a task manually. That doesn't do much for us, right? But it's like we can add a task later. We can inspect the task. Okay. So now we actually have most of what we need for the durability part. We have like the persistence, right? We can save it to the database, but obviously we still need to change a few things. So the question is, what do we need to change? Do we need to change anything around foo? That would be unfortunate, so we don't want to. Do we need to change anything around views? Yes. Yeah. We need some changes, and that is we basically need to invoke foo differently, right? So we need to put it into the box. That's it. Right? We need to put it into the box, but we also need to finish the box. So foo is on. I'm sorry. The task is only like the first step on the box. So let's create the actual box, all right? And let's call it a scheduler. So what's a play here, right? What are we gonna do? So
the plan is to be able to when foo is invoked, be able to take the metadata of that and store it as a task.
correct.
Got it.
That's exactly what we're gonna do. We're gonna do one more thing though. We're gonna do one more thing. So remember that foo took like 15 seconds. Huh?
Yeah.
So if we go down that route of recovery naively, right? And we say we started like 10 times, right? I opened 10 browser windows, I started 10 times, I crashed the server, I start the server. And then if recovery means we restart it sequentially, one after the other, and wait for its completion, there's gonna be a problem, right? There's because now we wait 15 seconds, wait 15 seconds, wait 15 seconds, wait 15 seconds. So we don't want that. So one slight change in the semantic is that we will now not call foo sequentially, but we will call foo asynchronously. So we're not going to get a value from foo immediately. We first get a handle, and then we wait for the handle. So basically, a handle is a promise, right? So or a handle represents either the value, if you want to think of it like that, or the handle represents the computation itself, right? So we first we're gonna create a handle for the computation. So let's see. That is not that's not totally unreasonable, but so is it completed? No. We don't need the function. All we need here is a few shortcuts. So success, that is none. That's going to be the value when it succeeds. And then we're going to do a failure. That's none. And we need a lock. Now that's unfortunate, but okay. So why did I say that's unfortunate? So threading. threading is brain breaking, right? So it's like it's actually pretty tough to get like multi-threaded code right. So I hope we're gonna get it right, right? But it's really easy to like build a foot gun into it. But all right, so we'll give it our best shot. So we need that to first. So we will start the function execution in its own thread, but then return the handle, and the calling thread can use that handle to wait for the value of the function. Right? So that's what we need. What we need that for. Okay, now we do a thing here. Set success. All right. So is that right? Like completed is true. We set the success. We set the success. That is all nice. Okay. That's actually all we want to do here. You know what? Let's say success value. And of course, what we need to do is we need to acquire the lock. We basically do the same thing with failure. Here, instead of a value, we get an exception. We say completed true, we say failure. Okay. Now, one more thing that we need to do once we set the value, everything that's waiting on it will be notified. Otherwise, the waiting threads just hang there, right? So it will be notified. All right. And now the most important part here, the get result. And the get result. It's the tricky part with self.log. That's not wrong. While not self-completed, self-log wait, correct? Nice. Almost. Hey, the chat's not bad. We need to turn this around. If the failure is set, then we will not return something. We will raise an exception, and we will just use whatever we set here as the message. And if not, then we will simply return self-success. So that's it. That's a so first we acquire the lock. Yeah? If you're not completed, we wait. Now that's a tricky part. So the wait part here is going to release the lock, so something else can grab the lock. Yeah? However, when we come back, it will reacquire the lock. Otherwise, it's not going to come back. So so any thread, right, any caller that calls get result will wait on the lock. Yeah? And so we'll try to acquire the lock. We'll wait on the lock. Then if it gets the lock and the thing is not completed yet, it awaits, but it will release the lock while it awaits. And then when it comes back in here, it's gonna get the lock back, right? Again, threading is brain breaking, right? So that you can only do it wrong. So it's unfortunate but true. Okay, and now we're gonna build
other handles won't be able to try and access if it doesn't release the lock while it's waiting.
So what we're basically trying to do is avoid all race conditions. That's about it.
Okay.
And so what we're doing here is we make sure that this is a mutually exclusive area. There's one thread in it. Yeah? And yeah, that's it. There's one thread in it. All right, so now we create a scheduler. So the scheduler is going to hang on to like all of the handles that are ongoing. And then it is also grabbing, it will need a lock because, again, race condition. And here is the meat of the thing. That is how we put our thing into a box. So we give it an ID, we take the function pointer, we take a bunch of arguments. Python also does keyword arguments. Let's just happily ignore that right now. Okay, so now what we're gonna do. First things first, we grab the lock because we are accessing the common data structure handles. All right, so first thing, let's check if the UUID is in handles. All right, so have we put that thing into the handles already? If so, then we just return that. Done. All right, so we're done.
It would be already completed.
Not necessarily, but it was already invoked. It may still be ongoing.
Got it.
Yeah, it may still be ongoing, but it has already been invoked, right? So it's like this is our deduplication thing here. So so at this point, we know that the UUID is not in the handles, right? So that we know. Oh, what the? Let me see why it does not like. It's not closed. Oh, okay. Now here we go. All right, what are we gonna do now? Gotta create a task. That's first time we write to the database. Why? We need to write to the database before we do anything else, right? Otherwise, we can't recover. We cannot call the function yet. We first have to write the intent to execute that function to the database. So that's what we're going to do here. Thanks to Django's ORM, that's actually pretty straightforward. Going to do a get or create on the UUID. So if it's already in there, it's already in there. We cool with that. And if it is not, what we're going to do? We set the status to pending. We set the function name. Okay, we got to do that. You know what? Let me just write function here as a placeholder. And then the arguments, we do a JSON nums of the args. And I believe that's about it. That should do it. Now, that's obviously a string. That looks right. Okay, cool. So now we're missing a bunch of things that we need to import here. One was what did we have? One was JSON. We also obviously need our we need our task, and that's good. Now we cannot put a function pointer into the database, right? Problem. So that doesn't work. So we need to represent it somehow. Python is pretty cool, with like meta programming and whatnot. Ask the function itself, right? And it's like, hey, what's your name? And so we're gonna write a little helper. Obviously, we need enough stuff, from the function, so that later on we can recreate it. So first, let's grab the module. Okay, that's nice. And then let's do a function if no. we use the inspect module, and we say method if a functional method, or we want to make sure it is actually a function. Right, then we say name is function almost. Yep. Else we just raise an exception. Nice. We just take that and then we do a format string, and we take the module.
You got a typo from module variable name. I think you intended module.
Absolutely, thank you.
Which I mean, autocomplete doesn't matter, but and then it looks like is method probably like that.
Damn, man.
This is cool. It's humbling.
Absolutely. You know how long that would take us to actually like chase that one down? Huh? Terrible. All right, so now we just get the fully qualified name of the thing. Nice. Looks right to me. And then so instead of the function, get the fully qualified name, and later on we basically have to do the opposite, right?
Nice.
And just like grab that thing to execute it. Okay, cool. So now we got that, right? So now we have it saved as a task. So okay, what else is there? So at this point we definitely, man. At this point we have a task, right? So we have this task object. It's not empty because we either got it or we created it. So let's create our handle. All right. And then we add the handle to, yup, exactly. So now we have a handle, we added that handle. Okay, so now what we're gonna do? Any ideas? Well, that's trickier than you think.
Well, this is after we've created the run function here, the run method, for us to get all the metadata from the function so that we can store it to the database. We're gonna have to recover somehow, right? At some point.
First, yes, exactly. So we have to recover somehow. We also eventually have to call the function, right? Because actually we said run, but we didn't run it. So good point. We don't know where we are at though. So it's like, what's the task? Did we get it or did we create it? So first thing we want to do here is check the status of the task. Yeah, if the task is completed, then two things. Yeah, if we set a failure, then boom, exactly. Then we throw out the failure. The task doesn't have a result, but a success. And then we also need to do a JSON loads. Right. So good. Now, and obviously after this, we can immediately return our handle. Cool. So we shortcut it, right? So if we already did it and we have the result in the database and stuff, we just shortcut it, right? So we're done. We don't have to call it again. All right. So then at this point, right, we know that the task status is pending. Otherwise, we're not here. Okay. So it's pending. We haven't done it yet, right? So now is the time that we actually do it. But again, we're not calling it in line. We throw it on a thread. Yeah. So no, thread. Yup. Yup. Almost. So do the UUID. Need the UUID. We need the handle. We take the function and we take the arguments. That's what we're gonna do. Good. And then we start the thread. Okay, and then we return the handle. Okay, cool. Now we basically have something running in the background, right? Boom. And we have the handle, and with the handle we can wait on it. Okay. Obviously we don't have anything running in the background because we need to define run task. Right? And then we have the UUID, we have the handle, we have the function, we have the arguments. Fantastic. All right. So what we're gonna do? Let's see what that thing says. So try result. Function arguments. Fantastic. That's exactly what we want. No, I did not see that coming. Very good, very good. Didn't see that coming. So, okay. So far, I haven't been like super impressed with the AI helping out. Was nice, right? But sometimes you imagine weird things. This is really good. This is a very good line because race conditions. You have multiple threads. You have race conditions left and right. Yeah, and so this particular line, the way that the chat wrote it is pretty good because it translates to exactly one command, exactly one. Yeah? It's one SQL. It's not multiple in a transaction or anything. It's one. It's one. It's a conditional update. So that's really good. It's missing one though. It's missing one. We give it one more. We want this thing to be pending because again, anything can happen at any time. While that thing here sleeps for 15 seconds, right? I could go in manually and already like alter the task and set it to success and stuff, right? I could do that. So I don't want my change to be overwritten. I basically want it linearized. It's a write once register. You can only complete the task once. Doesn't matter where you come from, right? Therefore, we are also checking that we are actually still pending. Even though here we think we're pending, somebody can come in at any point in time and do something with it. So we only want to set it if it's still pending. So, but the chat did good. Chat did good. Cannot be. That is. How good did it do though? Because now, okay, did good with this one line. But here it's subtle, man, super subtle. Yeah. But here, what if the conditional update failed? Because it wasn't pending. It was already completed, right? Do I wanna set it with this result? Or do I want to read it? Do I want to set it with the result that I got from the task? I always want to set it with the result from the task. Doesn't matter, right? I just set it conditionally. Maybe I did, maybe I didn't. All right, so we're not setting the result yet. Anyways, we do the same thing here. Yeah? We basically say object filter UUID. We still want the task pending. Very nice. Okay, so far so good. Same thing is true for here. We don't want that. Okay, so what do we want? We want finally. Almost. No, again, not even close. Not even close on that one. Okay, so now we're gonna grab the task again. All right, we grab it from the database. Here it must be completed, otherwise we're not here. Actually, it's like if somebody goes in just at the wrong moment manually in the admin interface, changing that back from completed to pending, then the whole thing blows up. But what we would need to do is basically write into the model that you're not allowed to ever go back. Right? But we're not going to bother with that one. Right? This is like let's not get too crazy here. We're already doing somewhat okay.
It's just a Friday afternoon.
It's just a Friday afternoon. Thank you. It's not a production system, so I'd be amazed if it even worked. So let's the rest of this afternoon is probably just Was it complete or completed? Completed. The rest of this afternoon is probably just debugging stuff, because at one, let me see, pending completed, yeah, because somewhere I called it completed and somewhere I called it complete, and that's gonna blows up in our face. So, all right, and now we're gonna do the thing that we already did before, and that is if the task failure is set, then set failure, that's right, and if not, then we set the success is also right. Okay, that's not bad. Okay, that's right. So that's it. Then our thread terminates. Done, right? And it's like we don't need to worry about the thread or anything else, because the handle represents the. You could almost say the handle represents the thread. It has a duality. The handle represents the result and the execution. Yin yang of life. And then we just gonna set like one. Let's do here global top level singleton object. Right? Easy. Okay, cool. So that was the heart of our operation, and we actually already like tackled a bunch of things, including like making sure that thing is linearizable with an asterisk, unless I come in and fudge around with it in the admin interface. But other than that, it's pretty linearizable. So I want to say we got most of the threading threads under control. So now we can actually start using it. So what we're gonna do. So again, this is what we had before. This is not gonna work anymore. Now we need from schedule. Almost no. We want the singleton object. So now we ask for a handle. Okay. We ask for a handle, and we give it the function. Not bad. Okay, and then now we immediately wait for the result, because what is what we did doing here? So we could actually use that now also to implement an async HTTP interface, right? Where we just get a reference back for our handle, so that the client can go on about its business, doesn't have to wait around for 15 seconds. And then later come back to us and say, hey, I have a handle for something, give me the value. Cool, but we're not going to do that. That's like an added benefit of this whole way, how we implemented it, but we're not going to do that right now. Okay, one thing though, once again, hey, what's that UUID? Okay, how about this? It's like easy, huh? Random. Whoa, okay. Yeah, so, okay. That's a terrible idea. Absolutely terrible. Because what would happen if the thing crashes, right? That's good enough. If the thing crashes, thanks to our random ID, there will be a task in the background, and that task will basically just like sort itself out. But if the client retries, every single retry of the client is going to be like a new task, right? But we want a retry to be like logically the same task. Therefore, we need the UUID, right? So let's not set it. It's never a good idea to set a UUID on a platform level. Bring it all the way up to the application level. So therefore, we make one more change. We accept the UUID here. And in order to accept that UUID, we have to fudge around a little bit with where are my URLs? We have to fudge around a little bit with the URLs. However, Django, it's not that hard. UUID done. Okay, that should have been it. And then now we get the UUID here, and then we add it here, and then we start our function foo, and we immediately get the result, right? So from the outside, you don't see much difference, except the fact that now you need to set a UUID, and that's about it. Our guy is still running. Fantastic. So let's look at that. Like, that works. And so it's like, how confident are we? Nothing works on the first try. So again, we need to set a UUID. I'm gonna get real creative. I'm gonna say 1. Okay, fair enough. To require positional arguments. All right, handle. Never trust the chat. Just don't trust the chat. So was that actually the problem? No, that was not the problem. It also wants arguments, I believe. Let me see. Where is it? Scheduler. Scheduler. No. Run. Here, dm-foo. It's going to be the rest of the day. Oh, what the hell? Tripwires, left and right, tripwires. Oh, okay, so we didn't want that. Condition is not callable. Yeah, that's fair. That is fair. Where were we at? We were here. My fault. It's just a lock. It's not a function that returns a lock. So do we have that anywhere else? Not here. Okay. Looking good so far. All right. Okay. So result 30. Let's see. I was like, oh damn, actually worked. Good business fool. Wow. Okay. So we believe that took about 15 seconds. We don't know because we were debugging in the meantime. However, if we do that again, that should actually be instant. It's instant, because now we're just reading it from the database, right? Because it's the same UUID.
Right.
Do that again.
You can't use the one ID again and expect it to run from scratch.
The logical execution already completed, right? It's done. Obviously, we could also now say, let's delete it. And then later on, you can come in with a new, see? And 2 took equally long. And now it was like loading. And then now it's instant, right? Boom, done. Okay, so now we have 2 tasks.
Conversation.
So let's do that one more time. Let's look here. There it is. There's our task. It's pending. Still pending. A watch pot never boils. Okay, now it's completed. All right. So that was the thing, right? Okay. Now, if the process crashes in the middle and if we restart, what is there to do? Nothing, because all of it is completed, right? But what was there to do? Let's do it. Let's do this. So,
what was that all for? Let's see
what was that all about?
Yeah, let's see the magic now.
Now, the cool thing is actually, like, on one level, you actually said something like super interesting. What was that for? That's a cool thing. If nothing happens, ideally it wasn't for anything, right? So that's why I said, let's not put it on a message queue. Let's not send it off somewhere else. Let's not have a remote scheduling step or anything. Let's just call a freaking function, right? Now, what we did, we just called a freaking function. Now, if we wanted to be fancy, which here we are not, and it's like currently I don't even remember how to do that. We don't have to write this either, all right? So we can have something like super nice, where we do some Python decorator magic, and we can then, instead of this, we could write this. So durable, and then here we give it the UUID. Fancy, right? So that looks pretty cool. And if you wanted to get the handle for it, you can do something like, I don't know, invoke, and then instead of the result, you get the handle, right? But it looks just super cool. But let's not go there because it's just syntax sugar. Cool syntax sugar, but it's just syntax sugar, and I forgot how to do it. But ask the chat. That I'm sure ChatGPT, after looking at the code, that it should be able to do. So, but oh damn, I lost my train of thought, and I think I started 4 already. Did I? No. But the cool thing is, right, we didn't change anything. That's the point. If nothing bad happens, it should basically feel like before, with minimal changes. That's a cool developer experience, right? Minimal changes, minimal toil. Don't make me think. I don't want to do anything differently, right? I just want to be able to recover when it crashes. All right, let's do that. So, okay, I didn't punch an enter yet. So let's punch it in. Boom. Yeah. Boom. Oh, there's one pending. Boom, boom. Crash it. No, crash it. Okay. Did I crash it in time? It looks like we crashed it in time.
Server went down.
Server went down. We can check that it went down because if I do a refresh here, it's gone.
Yeah.
Now, this is what we talked about before. There are 2 levels to recovery, right? The first one is somebody needs to restart that process. Somebody's going to be me. Yeah. But in a production environment, it would be some kind of like supervisor, like for example, Kubernetes. I'm saying supervisor because in that case, I am interested in its supervising capability, right? So therefore, I refer to it as a supervisor. So we wanna start that guy. So now let's restart. Okay. So now we restarted the process. Awesome. Let's restart this. Okay. Okay. Pending though. Oh, kind of sucky. So this is never gonna change, right? So because so far all we did is we stored it in the database, but we didn't actually implement any recovery logic, right? So now we're just sitting there knowing that there is a task that's still pending. All right. If we did it right, all right, at least if we do this and we call it again, then eventually it's going from pending to completed again, right? So it's like, actually, let's stay here, right? It's going from pending to completed. But we relied on the fact that the client retried, right? That's the whole thing that we didn't want. Huh? So we basically just need to write some recovery logic. So now, boom, completed. Doi. No? Okay, so we want some recovery logic. That's the whole point. So let's do this one more time. 5. Pending. Cool. Killed it. Did. Also did. Okay. So there's a ton of ways you can implement recovery. And so it's like we could do it on a loop. We could do it on whatever event. Yeah. Here we're just going to do it on startup. All right. So when we start up, we recover. That's all we're going to do.
Okay.
Can't get more fancy, but we will not. Okay. So what we need, we need some helper that recovers. So let's just throw in the recovery here. Recover. Yeah. All right. So what we're gonna do? Yes. Okay. Okay. All right. Let's see what it comes up with.
Write this before.
Huh?
Almost like it might have seen you write it before.
Do you think it remembers? Maybe it does. Let's see. Let's see. Because down there with task filter and stuff, it didn't do the best job. Mm-hmm. So we want pending stuff. That's right. No, that's wrong. Okay, that's wrong.
Oh, that's a bummer.
What the hell, man? That's all wrong. Okay, no. So none of that is great. So it's like it did a good job. It did a good job on figuring out that it has to iterate through everything that's pending. After that, it's like no. Okay, so if we run into a mistake, then there's like the recovery of task. And here, what is it? It is a task with that UUID failed. Okay, so what we want to do. So first off, now we have the task. So first we need the module name and we need the function name. and we stored that. Yeah. Okay, now it's right. And then we want the module, so we need to import. Okay, it's redeeming itself. We want the module. We import the module. Then we want the function that we got from the module. That's right. And now we want perfect. I mean, that's nonsense. We don't want to do that. We basic, and now that's okay. That's right. Okay, that's right. So we don't want to call it inline DOI. Yeah? We want to call it via the scheduler, obviously, because the scheduler that does everything. So I think that's it. So we're basically just going through the task. It's like me being the client, clicking the refresh on the tab, right? Now instead of like clicking the refresh on the tab, that thing clicks the refresh on the tab. It just iterates through all tasks that are still pending and then throws it back on the scheduler. And the scheduler is going to run it for us. So now the last thingy is basically, okay, where are we going to put this? And that we want to hook into Django's startup sequence. Any startup sequence is already a little bit iffy. So took me a little bit until I figured that out. And I didn't really figure it out. I basically just copy and pasted it from somewhere. That's the app config, that's good. And then here we're gonna say class durable config for our app. It is the subclass of app config. So
when Django restart or you start it up again, it'll call recover.
It's going through this class thingy. Gonna call self. We actually, yes, that's almost correct. There is thanks to Django's like auto reloading when I change some code. There are a few different modes. We only want to call this in one. So that is set via a command line variable, and on that one, okay, now we can import it here. Okay, that's why we did this. Yeah? That's why we did this. So that the internals of this, not that important. I don't understand it. But what I do understand is that Django goes through this path when it's basically ready, meaning when the connection of the database is available, when the ORMs are set up, when everything is set up. Because if you do it too early and none of it is ready, right, then you can't recover neither. So the important part here is on restart, we're going to call recover. That's about it. So let's look into that. Obviously, we're still down. Let's run the server and see what happens.
Fire it up.
Yes, that's exactly what I meant. Okay, there it is. There it is. Right? And so number 5, that was the one that failed. I'm not clicking refresh right now, right? Because that's the whole point. Number 5 failed. And then after 15 seconds, let's hope it comes back. Oh, here it is. Boom. We have our thing, right? And then let's do this one more time. 6, 7, 8. Let's see how fast I am. 6, 7, 8. They're all pending. Boom. Failed, failed, failed. Okay. They're all pending. This guy is gonna fail. Okay, let's restart it. Pending, pending, pending. They're all gonna get restarted. I can now also restart here. It's actually not going to trigger another execution because I'm getting the same handle back that I'm waiting on. Result 33 for 6. Result 33 for 6. Because I was waiting on the same handle, right? So it's like we deduplicate on the handle. And so therefore, it doesn't matter where we come in from the system to trigger that restart. And that's basically it. That's what we did. Right? And now we have automatic recovery. Automatic recovery on restart of the process. So now we rely on the fact that an external recovery mechanism recovers the executor. And after that, the internal recovery mechanism will recover all of the executees, everything that executes in our thing. And that's it. It's a pretty good starting point. Yeah?
Nice.
Right? And it's implemented right in your environment. So if it's Django, you can implement it right into Django. It is right in the same persistence alongside your application. Whether you want that or not is a very different question. If you want your control plane data to be in the same database as your data plane data, that is questionable. Yeah? But that's the choice we made here in order to keep it simple. And we also have now the opportunity to write an async API because we have an async handle, right? So generally, here you can see that here. Now, obviously, that stuff will deduplicates. But if I start yet another one, the lifetime of the callee, the function that is running in the backend, is imposed on the caller. So this guy has to stick around, right, for the result to come back eventually. And you can decouple that via an async API, right? So you can basically, instead of making it wait, you can return a handle, a URL, to call later once you want the result. Right? And then you can either call it then synchronously and wait, or you call it asynchronously and you poll. Right? But therefore, because of the way we implemented it, because we implemented it via threads, we already have everything we need for a super small extension to implement an async API on top of it. Super cool, super cool. Because now you decouple the caller from the callee. The caller doesn't have to stick around.
And this looks like you could use this technique to write nice, just as many sequential functions or flows as you want, and go, because I'm thinking of a call graph, right, where you'd have a bunch of nested functions. If you nested a bunch of them, it would all recover.
It would recover, but so this is a bare bones starting point. It is basically a one-off task, right? Or a one-off workflow, or however, one-step workflow, one-shot workflow, however you want to call it. And if that function calls 5 other functions, the task framework is blind to it. The task framework only has one function to call, the end, right? So it cannot recover to a certain point or anything. So there is, from the point of view of this call graph, there's no call graph from the point of view of this task framework. It cannot track either chains. It cannot track an async call graph. It can't do any of that. That's basically what we do at Resonate, right? So this is a very bare bones minimum, and it's not super sophisticated, right? But you clearly want like more capabilities there. And one capability would be the async call graph.
Yeah, I guess. But my question is then just about using the schedule run call method on multiple functions in a single flow.
Can't do it. They do not compose.
They don't compose yet. Okay,
They
so
do
it's
not
really
compose.
just a one-off. A one-off.
One-off.
Got it.
A lot of workflows are just one-off workflows, right? So it's like, or at least in your head, you start off with the idea of like, I just need a one-off thing. So I just need a reliable call one function. Usually it doesn't end there, right? Because functions call other functions call other functions. Yeah. And then so the only thing this task puts in a box is the top level thing, right? So it's like this entry point. All of it is put in one box. It's not nested boxes, right? It's not like Russian dolls or anything like that. It's not chains. It cannot chain one task depending on the other task or anything. None of that exists, right? No nesting, no chaining. We didn't build that into it. But that's why it's like more sophisticated programming models like async await and Resonate's distributed async await take care of that part, right? Where we basically, whether you want to call it Russian dolls or Boxify or whatever you want to do, with an entire call graph. And not only a call graph on one machine, but a call graph across machines, so that you can use a similar experience and call functions remotely for fan in, fan out scenarios, right? So now you're basically rounding this very starting point, rounding it off to be an actual programming model. What we did here was not a programming model. This is an early experiment, right? It's cool because it kind of shows you it's like fairly little effort. You can create something that is durable. And it can compete in some level with like putting something on a message queue, unless you're using something like Celery to do a fan out, fan in. But if you use Celery just to make sure that the function that you're calling will actually be retried, right? Then this is not bad. It's not a bad starting point, but it's nowhere near like a full-fledged solution that gives you a programming model where you can build an entire system on.
But it does show you how you can create a durable execution for a single function in a single node.
And it has a bunch of ingredients, so it's like that you can now start to play with. So one of the ingredients is, hey, why do I actually need that ID? Or because now it's like when it crashes, I have multiple physical executions that all compose into one logical execution. And to make this connection, I need the ID. Cool. Can I generate the ID on the server? That depends. If you think that the client will retry something, will try to reconnect to something, then you should not, because every single connection attempt then by the client would mean it's a new execution on the server. If all you want to do is make sure that if the client in the middle like crashes, goes away, or you crash and go away, and then you restart that particular one, then you can generate the UUID on the server. So now you have a lot of things to think about, right? You can look at these things in like linearizability questions. Can I ever see a result 39 here, but then later on I get a result 77 over there, right? It's like, do I have any race conditions in the system? I always need to read from the database because I actually don't know if somebody else completed it beforehand. Right? Oh, let's try that real quick. That's the last thing we try. Whether it works or not, it doesn't. It's like, that's fine. So we have,
let's try it.
Let's look at that. So it's like 8 and then success is 89. So the chances that success is going to be, what did we set success to? Where's my function? Business. 100. Okay, so maximum. The chances that the value is 500 is zero, right? Because it's a random integer up to 100. So let's do this. So we need to set it to completed, and then we set the thing to 500. Okay, let's be fast. We do that for the last one. We do that for 10. So let me see if I'm fast enough. So we start it up. We go here. We go to the task. There is 10. We set it to completed. We set the success to 500. Save. Okay. We said, okay, we beat it, set it to 500. And now we want to see this result 500. So even though it ran the function and produced a random integer between 1 and 100, we beat it to it. I came in, beat it to it, set it to 500, and that is what the thing now also sees, because we did not blindly accept the value of the function, right? We always went through the database first. Always went through the database first. So that's why we did this whole like one line filter update thing, and then later get the task again, stuff like that. So there's a lot of things you can explore in the realm of concurrency and also in the realm of distribution. So in the realm of non-deterministic execution order or non-deterministic partial order, and in the realm of non-deterministic partial failure, that you can explore with these simple experiments. So there's a lot to think about. And then obviously, if you want to build this into an entire, like in itself consistent programming model, you have to add a lot of like concepts and mechanics to it. But I mean, you can do a lot in an afternoon.
Yeah, apparently. Speaking
Pretty
of
cool,
experimenting, would love to promote this this example, share this example with anybody who's following along. Are you gonna make this code available on your GitHub?
Yeah, absolutely. Gonna
Awesome.
take it. It's like make sure that there's no blatant mistakes in it, and then as is, I just gonna upload it, and then everybody can run it.
Cool. Yeah, because that would be a great place to start experimenting from. It does seem like quite a bit of magic happens in your ability to manage threads. That's like kind of the hard part there for this specific example. So learning.
Hey, threads are always full of surprises. Yeah, full of surprises, and it's like it's clearly not my favorite programming model because it's hard to reason about. Threads are very hard to reason about. That's why in general I try to keep it like super straightforward and simple when it comes to threads, and even then they're already pretty complicated. So yeah, there's an element there on the threads that is worth looking into, like also the documentation of the individual methods, right? So for example, if I already have a lock, if I wait, if I wait, the lock will be released. But once it comes back, I will be guaranteed to have it again and stuff like that. So it's fairly tricky to reason about it.
Cool. Well, that was a pretty awesome live coding session, Dominic, and
Hey,
really awesome example of durable execution.
surprised it went so well. Yeah, it's like only a few bugs encountered, and the AI tripped me. Yeah? Added two parameters that weren't supposed to be there.
Dude, that Copilot, man. Sometimes it gets wrong, gets the coordinates wrong.
Sometimes it gets the coordinates wrong. Exactly. Cool.
Yeah, Copilot. Cool. Well,
Awesome.
looks like we've got some folks following along. I don't see any questions in the chat, but if you do have questions, please feel free to follow up on any of our channels. We're on Dominic's on Twitter, where you're watching. Maybe you might be watching this now. YouTube, Twitch. We're also streaming to Twitch right now, and LinkedIn. But on any of those platforms, and we also have a Discord community going. So if you've got any questions at all, want to run this example by Dominic, anything at all, jump into one of those platforms or our Discord community, and we are super excited to chat with you, or do any sort of design sessions at all that you might be interested in doing when it comes to durable execution and distributed async await.
Oh, I love design sessions.
Yeah. Cool, man.
All right, cool. Hey, thank you very much. Yeah. Thanks,
Good.
Colby.
Good way to spend a Friday afternoon. Thank you, Dominic.
Yeah.
Thank you very much.
Awesome. And see you next time.
See y'all.
Bye-bye.